Archaeology has a problem. We can currently prove that humans were cooking hundreds of thousands of years before we can prove they knew how to make fire on demand. And the evidence is not a hearth, a pot, or a burned dinner. It is a pile of tiny fish teeth. Put a raw fish in front of a modern human, and we immediately begin summoning infrastructure. Pan, stove, gas, electricity, salt, oil. Now remove the stove, pan, electricity, lighter, matches, metal, pottery, kitchen, house, and supermarket. What remains is a surprisingly difficult question. How far back can archaeologists actually prove that humans deliberately cooked food? The obvious answer seems easy. Find the oldest fire associated with humans. Declare somebody prehistoric Gordon Ramsay. Roll credits. Unfortunately, deep history refuses to organize itself that politely. Fire is not cooking. Burned food is not necessarily cooked food. And knowing how to use fire is not the same thing as knowing how to create it. The first kitchen we can currently recognize looks instead like dental evidence left behind after dinner disappeared. The intuitive story goes like this. Humans mastered fire, and then humans cooked. It is a beautifully neat sequence, which is exactly why the archaeological record causes trouble. Fire can enter a human site in several ways. Lightning can ignite vegetation. People can encounter a natural blaze, carry embers, maintain a flame, or repeatedly return to a reliable source. Even when archaeologists establish that humans and fire occupied the same place, they still have to show that food was deliberately exposed to heat rather than burned by accident. A bone can fall into a fire after the meat has been eaten. Plants can be fuel, sediment can move. Archaeology does not get to point at something blackened and shout, "Dinner." It has to reconstruct intention from residues after time has deleted almost every useful file. Consider Wonderwork Cave in South Africa, where Acheulean deposits roughly 1 million years old preserve microscopic evidence interpreted as in situ burning, including burned bone and ashed plant material. That matters enormously, because secure traces of fire this deep in time are rare. But it still does not automatically give us a meal. Burned bone does not arrive with a receipt saying cooked before consumption, and plant material might be fuel rather than food. A human-associated fire can exist without preserving cooking. Wonderwork therefore demonstrates the first obstacle with unusual clarity. Finding ancient fire is already difficult. Proving ancient cooking is harder, because now we are not merely identifying combustion, we are identifying what somebody intended the heat to do. If fire itself cannot prove cooking, we need evidence preserved in the food, and that is where the story moves north, to a lakeshore. This distinction also changes what direct evidence means here. Archaeologists are not claiming that a single object announces, by itself, "I was cooked." The strength comes from several independent traces pointing toward the same behavior, the kind of fish represented, which anatomical parts survived, where those remains occur relative to fire-related material, and what heat did to the teeth themselves. One clue can be ambiguous. A stack of clues that agree becomes harder to explain away as coincidence. Around 780,000 years ago, at Gesher Benot Yaakov in the Hula Valley, hominins repeatedly occupied a rich freshwater environment. Imagine approaching the site without knowing that cooking may be hiding inside it. There is no preserved grill, no frying pan fossilized under a tasteful layer of sediment, no prehistoric food blogger leaving a review. Instead, there are archaeological horizons containing stone tools, traces associated with fire, and an astonishing quantity of fish remains, more than 40,000 of them. The number is impressive, but archaeology becomes powerful when it stops counting objects and begins asking how a pattern was produced. Fish can accumulate naturally. Predators, water, and decomposition can rearrange remains. Humans can catch, select, process, and eat them. Each process leaves a different fingerprint. The GBY assemblages were not simply a random cross-section of everything that once swam past. Researchers found relatively low species richness and strong representation of particular large cyprinid fish. More importantly, the anatomy of what survived was bizarre. Fish have bones. This is not normally considered breaking news. Yet in the relevant GBY archaeological horizons, ordinary fish bones were nearly absent, while pharyngeal teeth, the hard teeth located deeper in the throat apparatus, were overwhelmingly represented. In the studied horizons, more than 95% of the preserved fish elements consisted of these teeth. That creates a forensic puzzle. Why should a natural fish accumulation look as though an anatomical delete button removed most skeletons while sparing the same hard structures? Taphonomy, the study of what happens to an organism between death and discovery, becomes the detective. Water moves things. Animals chew things. Chemistry dissolves things. Sediment crushes things. People break things. Time, generally speaking, is not a responsible archivist. Researchers compared the archaeological fish assemblages with naturally accumulated fish remains and found meaningful differences. A single missing bone proves almost nothing. Thousands of remains showing a structured pattern can become data. The archaeological record is not a photograph of the past. It is a damaged hard drive, and taphonomy helps researchers decide which files nature deleted and which may have been altered by behavior. The missing bones tell us something happened. The surviving teeth may tell us what. This is where the evidence becomes wonderfully absurd. Part of the history of cooking may be written in crystal size. Fish teeth contain mineralized tissue whose microscopic structure changes when heated. Researchers used X-ray powder diffraction, or XRD, to examine the ancient pharyngeal teeth and compare them with modern fish teeth, experimentally exposed to heat. Think of the tooth not as a thermometer with a number, but as a rough heat recorder. Its internal mineral structure changes, depending on the kind of thermal exposure it experienced. In the experiments, heating between roughly 200 and 500 degrees Celsius produced measurable changes in crystallite size, while temperatures above about 600 degrees produced much more dramatic alteration and eventually signs of calcination. The GBY teeth matched the lower temperature pattern, consistent with exposure below about 500 degrees Celsius. Crucially, that does not mean the fish flesh itself reached 200 to 500 degrees. Those temperatures come from the experimental calibration used to interpret changes in the tooth enameloid. What the teeth preserve is evidence of thermal exposure. The argument for deliberate cooking comes from combining that signal with the rest of the archaeological context. The tooth is effectively a crude geological heat recorder with terrible user experience. Nobody designed it for archaeology, yet its mineral lattice kept part of the story anyway. And one heated tooth would still not be enough. A wildfire can heat things. A carcass can fall into a fire. Sediments can move. Bones can disappear for reasons unrelated to cooking. This is why the GBY case depends on several signals aligning rather than on one magical clue. Many pharyngeal teeth in the relevant horizons were spatially associated with concentrations of burned flint microartifacts interpreted as phantom hearths. The fish assemblages differed from natural accumulations. Particular large fish were strongly represented. The anatomical preservation pattern was unusual, and XRD indicated comparatively moderate thermal exposure rather than wholesale calcination. Similar patterns also recur across several occupation horizons, rather than appearing as one lonely accident. Taken together, the researchers argued that the fish were deliberately heated and eaten at the site, making GBY the earliest currently reported direct evidence of cooking by hominins. The logic is not, we found something warm, therefore chef. It is forensic triangulation. Location says one thing, taphonomy says another, species representation says another, mineral structure says another. None is a security camera pointed at a prehistoric cook. Together they become something closer to a behavioral fingerprint. That repeated pattern matters because ancient sites are noisy. One burned object can be an accident. One strange cluster can be movement after burial. But when similar relationships recur across occupation horizons, the explanation has to account for repetition. In archaeology, repetition is one of the closest things we have to seeing a behavior happen again. At this point, our visual imagination becomes dangerous, because the moment somebody says, cooked fish 780,000 years ago, the brain wants production design. Were the fish placed beside flames, heated over embers, cooked with hot material, prepared by some method that left almost nothing archaeologically recognizable? We do not know. The evidence supports deliberate heating. It does not preserve an instruction manual. That distinction matters. Archaeology is most trustworthy precisely when it refuses to upgrade possibility into fact. We can reconstruct that heat altered the teeth, that the remains formed non-random patterns, and that fire-related features occupied the same archaeological space. We cannot zoom through time and inspect the recipe. The meal therefore becomes strangely clear and strangely inaccessible at once. Somebody at GBY appears to have understood that fish plus controlled heat produced food worth preparing, yet the smell, timing, gestures, texture, and division of food are gone. We can see the behavior, but we cannot enter the evening. Once the fish becomes convincing, the timeline itself breaks. A Nature study published online in December 2025 reported what its authors describe as the earliest known evidence of deliberate fire-making, from a buried land surface at Barnham, Suffolk, dating to roughly 400,000 years ago. The evidence combines heated sediments and fire-cracked flint, hand axes with 2 fragments of iron pyrite, a mineral used in later periods to strike sparks with flint. Because pyrite is locally rare, the researchers argue that it was deliberately brought to the site for fire production. Now place that beside GBY. Fish interpreted as deliberately cooked, around 780,000 years ago. Earliest current archaeological evidence, interpreted as deliberate fire-making, around 400,000 years ago. Cooking appears in the surviving record almost 400,000 years earlier. That does not prove that the GBY hominins were incapable of making fire. Archaeological first evidence is not an invention certificate. Fire-making may have existed earlier without leaving a trace we can presently recognize, and people may also have collected naturally occurring fire and kept it alive. The record tells us where convincing evidence currently survives, not when a technology was literally invented. But the paradox destroys the neat ladder in our heads. Discover ignition, master flame, invent cooking. History does not owe us technological release notes. We tend to compress mastery of fire into one cinematic moment. Heroic hominin discovers spark, tribe gasps, civilization DLC unlocked. Real technological change can be modular. Imagine a tech tree rather than a ladder. A population might transport embers, protect flames, choose fuel, and organize around heat long before reliable ignition leaves convincing evidence. This is where the permission-level metaphor earns its keep. Finding fire is access. Maintaining fire is control. Producing it on demand is another permission level. Cooking is an application that can run before every fire system module is unlocked. A meal needs usable heat and enough control to expose food deliberately. That is why the GBY fish are more interesting than an oldest recipe headline. They force us to separate behaviors modern life has fused together. Using fire is not necessarily making fire. Burning food is not necessarily cooking food. And the earliest surviving evidence is not automatically the moment of invention. Later evidence expands the menu. At Border Cave in South Africa, archaeologists identified charred starchy rhizomes dating as far back as about 170,000 years, evidence that underground plant foods were being collected and heated. Cooking was therefore not simply a story about meat or fish touching fire. Heat could transform many kinds of food. Food processing can change the economics of eating. Heating can make some resources easier to chew or digest and increase usable energy, shifting part of the work before the first bite. In that sense, fire can become something like a partial digestive organ outside the body. Technology begins processing food before teeth, gut, and metabolism take over. That possibility attracts evolutionary arguments, and some hypotheses place habitual cooking much earlier than the direct archaeological record demonstrates. But this is exactly where a seductive story can outrun the evidence. GBY does not show that one fish meal caused the human brain, nor does it identify one neat evolutionary transformation produced by cooking. Evolution is not a software update triggered when somebody accidentally invents grilled carp. The safer claim is that deliberate heating let culture modify the nutritional environment before biology encountered it. Technology acted on food before food acted on the body. And that leaves one last mystery. If convincing cooking evidence survives at 780,000 years, how much earlier could the behavior itself be? Possibly much earlier. Proven? No. Some hypotheses place habitual cooking deeper in the history of Homo because of proposed biological and energetic consequences. But the archaeological record becomes increasingly sparse and ambiguous as we move backward. A cooked meal is almost offensively fragile evidence. Flesh is eaten, soft tissue decays, wooden implements rot, hearths can disperse, sediments move, water rearranges remains. Heat can come from natural causes. Even when something burns, we may not know whether it was food, fuel, waste, or accident. Imagine reconstructing tonight's dinner after 2 million years. Plate, napkin, sauce, building, gone. Perhaps the city too. One altered fragment under sediment is asked to explain the evening. That is preservation bias made visible. Our archaeological timeline is not a museum shelf containing every invention in order. It contains whatever chemistry, geology, and ridiculous luck allowed not to rot. A behavior can occur thousands of times without leaving diagnostic evidence, while one exceptionally preserved context can suddenly move the earliest secure date hundreds of thousands of years backward. The timeline, therefore, does not show when humans invented cooking. It shows the oldest point at which surviving evidence currently lets us make a strong case. So here is the answer. We do not know when hominins first began cooking, and the behavior may predate the surviving archaeological signal by a very long time. The earliest archaeological evidence currently reported comes from Gesher Benot Yaakov, where researchers conclude that hominins were cooking and consuming fish roughly 780,000 years ago. The case rests on converging clues: the enormous fish assemblage, the dominance of pharyngeal teeth, differences from natural accumulations, associations with burned flint phantom hearths, taphonomy and XRD evidence consistent with relatively low-temperature heating. Wonderwork tells us that human-associated fire reaches farther back than the secure cooking evidence. Barnum reminds us that using fire and deliberately making it are separate archaeological questions. Border Cave shows later heating of plant foods. None gives us a literal birthday for cuisine, and that is the real lesson hiding inside the fish. We like prehistory arranged like product launches. Stone tools released, fire unlocked, cooking added, civilization installed. But archaeology does not record invention dates. It records preservation. The first thing we find is not necessarily the first thing humans did. It is the earliest thing that survived in a form we have learned how to recognize. That difference sounds pedantic until it changes the entire story. Fire can survive while food vanishes. Food can burn without being dinner. Dinner can be cooked without leaving a recognizable hearth. A population can maintain flames without leaving evidence of how those flames were obtained. An entire technology may exist before the surviving record gives us permission to see it. The past is not a complete movie with missing subtitles. It is a handful of frames rescued from a film mostly burned away. Archaeology asks how much behavior those frames can support, and where reconstruction must stop. Around 780,000 years ago, somebody at a freshwater lakeshore heated a fish. We do not know their name, their species with certainty from this evidence alone, their recipe, their preferred texture, or whether anybody nearby considered the event remarkable. They certainly did not know that the most durable part of dinner might become a message to strangers in a future they could not imagine. They were probably just trying to eat, and that may be the strangest thing about deep history. It is often reconstructed not from the moments people wanted remembered, but from the tiny pieces they never imagined could survive. The flesh was consumed. The bones mostly disappeared. The lakeshore changed. Sediment buried the scene. Hundreds of thousands of years passed, until a microscopic change inside a tooth became legible to a machine. The meal vanished. The cook vanished. Even the fire vanished. But the tooth remembered the heat. If you enjoy stories where science takes an obvious answer and quietly makes it much stranger, subscribe to Oddplain. We will keep digging through the corrupted hard drive of human history, one improbable surviving file at a time.